So here we go. Last one. This is another common question they've asked the last couple of years, but they gave me this implicitly defined equation, some kind of curve, and they showed me the derivative already too. Okay. Well, they gave it to me, but they want me to show what it is. So for part A, you're just deriving this, so you should get 3y squared dy dt minus 2y dy dt, or y prime, same thing, minus dy dt. It's no product rule or anything here. I'm kind of surprised. Yeah, this is just, okay. 2 times a quarter is a half x, and that equals 0. They want us to solve for dy d. Why am I saying dy dx? Got too much differential equations going on in my head. Okay, so dx, dx, dx. All right, and they want us to solve for that. So we are going to factor out this dy dx, leaving me with this nonsense here. And that's going to equal negative 1 half x. They're going to multiply by 2, yeah. All right, but we got to divide by that. So we have dy dx is negative 1 half x over 3y squared minus 2y minus 1. That's not exactly what they have because they're going to multiply by 2 over 2 here. And that's going to make this negative x. They left a negative up top, right? Yep. Over this 2 is just outside here. 3y squared minus 2y minus 1. All right, so there we got that. B says there's a point on the curve G, there's a point P on the curve G near this with x coordinate 1.6. Use the tangent line to approximate this. Let's do this up here. So for B, a tangent line, we need 3 things: an x value, a y value, and a slope. So the x value, since we're finding the tangent line at 2, negative 1, is 2, and the y value is negative 1. dy dx of that is, I got to find, this. Well, the slope is dy dx, I got to plug in. So that's negative 2 over 2 times, plug in negative 1. So that is 3. Negative 1 squared is 1, plus 2, because we multiply by negative 1 there, minus 1. And you could leave it like that if you really felt like it, but we can reduce that to negative 1 over, because the 2's cancel, 5 minus 1 is 4. So the tangent line they are looking for is y minus negative 1 equals negative 1/4 x minus 2. And they want me to use that to approximate what's happening at 1.6. So I'm going to say that G, then okay, whatever, blah, 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 P. Okay, well, y is equal to, we're going to plug in 1.6. So that's going to give me 1.6 minus 2, just like that. I'm going to subtract that 1 over here too. And you can leave it just like that if you really felt like it. But 1.6 minus 2 is really negative 0.4 divided by 4 is negative 0.1 times a negative is 0.1 minus 1 is 0.9. That was B. For C, it says x and y both greater than 0. There is a point S on the curve G at which the line tangent to the curve is vertical. Find the y coordinate of this. Okay. Well, if the tangent line is vertical, that means the derivative is undefined, and the only way that can happen is when that denominator is 0. So they're asking me to solve this equation here, and they want the y coordinate, so that's fine. Point S, where the line tangent to the curve for the point is vertical, okay. On the y coordinate, okay, it's just a quadratic. So this is going to factor, does this factor nicely? 3y, this is a y. Got to get to minus 2, so it's minus 1 plus 1. Right, 3y squared minus 3 plus 1 minus 1, that feels good. And we're going to get y equals negative 1/3, or y equals 1. Since they told me y has to be greater than 0, the only one we really care about is this one. This one's not a solution. So that's all I wanted for C. And then for D, they're throwing some related rates at me here. It says a particle moves along this curve H, which is defined by a totally new function for some reason. At the instant when the particle is 4,1, we know dx dt, find dy dt. Great. So we are going to derive this thing. So D, zoom out a smidge. Okay. When we derive this, now I got to do the product rule. There we are. That's what I was expecting, College Board. It's 2 times derive x, leave y, plus 2, leave x, derive y, plus the, oh, I was wondering where this was. A lot of kids asking me, what's the derivative of ln of y? And it is this right here. 1 over y, dy dt. The derivative of 8 is 0. Let's double check my work. 2x prime y plus 2xy prime. 1 over y prime, that's great, equals 0. And we want to find dy dt. And there's two of them. We can solve for that. We know the point's 4, 1. And we know that dx dt is 3. So this is 2 times 3 times the y value is 1 plus 2 times, what's x? 4 times dy dt, which we don't know, plus 1 over y, but y was 1, so that's 1 dy dt. And this all equals 0. This is 6. This is 8 plus 1, so that's 9 dy dt equals negative 6, which means dy dt had better be negative 6 over 9, or if you're feeling frisky, negative 2/3. And that's all they wanted. Find dy dt, it's in the show the work. There you go. Wow.